This video we're going to talk about how to monitor the rate of reaction. This time we are going to measure the change in color intensity of a reaction mixture. So this is also a measurements of the physical properties, and we are going to focus on the change in color intensity. So when we try to measure the change in color intensity, we're going to use colorimeter. This will be the instrument that we're going to use. Remember the spelling of colorimeter, okay, is very similar to the word color. It is different from the words that we have learned in energetics. That one is calorimeter. Okay, the spelling will be different. Okay, pay attention to that. So do remember, okay, we're using colorimeter to measure change in color intensity at regular time interval. So when we're going to use it, okay, we can only use this when the reactions mixtures there is a one colored reactant or one colored product. Say for example, when the examples here are permanganate, which is purple, and the reactant side we also have C2O42-. This is colorless, and H plus is also colorless. So you can see that on the reactant side, okay, we have a purple solution. But in the product, okay, they change to very pale pink or almost colorless. Where water and carbon dioxide, they are also colorless. So you can see that the color will change from purple to very pale pink. Purple and pale pink, they are the same color tone. So we will see that in the process, okay, the purple color, the intensity of the purple color will get paler and paler and paler. Okay, so in this situations, we can monitor the change in color intensity to tell you the reaction rate. So the instrument, again, we said that, okay, this is colorimeter. Okay, so normally the question we ask, why the color fades, okay, in the process. Okay, remember the color intensities will be based on the concentration of the ions. So whenever you try to tell the color intensity decrease, you have to refer it back to the concentration of the ion. So in this case, okay, that will be the concentration of permanganate ion. As the concentration of permanganate ions decreases, the color of the solutions will also get paler. So this is the reasons behind, okay, why the colors fades. So if the reactant is colored, then we will know that the color intensity of the solutions will decrease because the reactant side is a colored solution. So this case is purple. And then afterwards, the purple chemicals is getting less and less. So therefore, you'll find that it will become very pale pink, or you may say colorless in the process. So this one, the purple will get, the purple color intensity will get less and less. Another examples, this side, okay, we'll have a colorless chemicals, and then we'll have an I2, which is brown in color. So this brown reaction mixture will become colorless because I2 will become I-, which is colorless. So again, okay, the color intensity will be from brown to colorless. On the other side, if the product is colored but the reactant is colorless, then we will say that the color intensity of the solutions will become increase. Okay, will increase in the process. Shouldn't have it become here. Okay, so for example, we have thiosulfite, which is colorless, and as time goes by, okay, they form some sulfur, which is yellow solid. So it will change from colorless solutions mixture and will get a more and more yellow solid. Okay, so maybe the color at the very beginning, the color of the solution mixture is like this, and then as time goes by, it goes to like this. Okay, it may be a little bit more yellow for you to see. Okay, so it will be the color intensity increases, okay, in the process. So during the process, okay, what we're going to do, okay, we're going to mix the reactant. For example, we mix the potassium permanganate together with the sodium oxalate solutions. Oxalate solutions is talking about the C2O42-. So we mix them together in a test tube, or we mix them in cuvette, okay? And then we're going to put this, actually test tube cuvette, actually it is a cell like this way, where you put the chemicals in it, okay? And then this one, okay, we're going to put it in a colorimeter. So the colorimeter, they got a place for you to put this cuvette in it, okay? So you put in it, okay, and then the instrument, they will try to measure the fractions of light absorbed, okay? So we'll just pass some light through here, okay, and then we're going to measure the intensity of the light, okay, and then passing through, and after getting into the solutions and passing through the solutions, we compare here. We can then know that, okay, the difference in the light absorbance or in the process. So normally the values, okay, that we measure, so we call absorbance. So we have two ways to measure the fractions of light. So one is called absorbance. This is normally the one that we have used. Absorbance, okay, actually is a percentage, okay. Percentage, that means that it will highest 100%, lowest will be 0. So normally we'll use 1 and 0, okay, as a range of the readings. If it is a dark color solution, that means that it will absorb most of the light passing through it, okay. So it will be a high absorbance. So it will be close to 1. So something like 0.19. 0.98, okay. What means by absorb most of them? So you think that, okay, with many light passing through, if this solution is very, very dark, then maybe a little bit amount of light can pass through. So this one we say that a high absorbance. On the other way round, okay, low absorbance, okay, means that you have a lot of light passing through here, but this one is almost transparent. So none of the light have been absorbed. So we will say that low absorbance. So in this case, okay, the absorbance will be very, very low. Okay, so it can be like that, and can also be present on the other way around. We call it transmittance. Okay, so transmittance, like the absorbance, it is expressed in a percentage. So we'll have a range from 1 to 0. So if it is a dark color one, okay, so when we have many light passing through, okay, we'll find that, okay, only a small amount can pass through, so the transmittance, okay, is very, very low. So the value here, okay, will be 0.12, a low value. But if it is a light color one or transparent one, okay, then you'll find that, okay, most of the light can pass through, can transmit through. So we'll say that that will be a high transmittance. So at that time, okay, will be closer to 1. Okay, so in DSE's levels, okay, right now normally we'll use absorbance, okay, instead of transmittance. Okay, so remember the value will be ranged from 1 to 0. The dark color one, okay, will absorb most of the color, so therefore will have a high value. Okay, so you can check the experiments, okay, how we're going to carry out this monitored experiments, okay, to monitor the change in color intensity. So in this case, sometimes we may ask why the absorbance decrease. Remember, absorbance will be related to color. So first of all, you have to relate it to the color of ion, and then you talk about the change in color, and you have to talk about the light, okay, being absorbed by these ions, and finally you go to the readings. Okay, so basically, okay, we'll go through a few steps like this. Again, concentration of ions, color of the solutions, light absorbed, and finally you go to the readings. So limitations to this ways of monitoring the rate of reactions. So it cannot be used to monitor the rate of reactions containing 2 or more chemicals with colored. Okay, remember we are measuring change in color intensity. Say for example, from purple to colorless or from colorless to brown. This one is okay, but we cannot measure change in color. Remember, change in color and change in color intensity are two things. Change in color intensity means purple to colorless or colorless to brown, but change in color means from orange to green. In this case, okay, we can't tell, okay, the rate of reactions. So for example, here this is orange chemicals, and the product we have chromium-free iron, which is green. So in this case, I can't tell. So this one as well, this is purple, and then, okay, this one that produced is brown. From purple to brown, okay, we cannot use this method to measure the rate of reactions. So we have a look of examples. Okay, right here, okay, we have a reactions between permanganate and also oxalate. So this one, okay, permanganate become Mn2 plus, permanganate become Mn2 plus, and then oxalate, sorry, C2O42 minus becomes CO2. Okay, so actually this one, okay, you have to be aware that it is a redox reactions, a half-half equation in the process. Okay, so in this case, okay, we found that it go from purple to very pale pink, and we didn't have any color as well. So this we can use absorbance against time. Remember, absorbance is a dependent variable. So absorbance, it will be at the y-axis and time will be at x-axis. And you can't see a unit right there because we did say that this is in the form of percentage. Okay, so therefore no unit right here. The first thing is asking about the colored species. What is the color of it? So very obvious, it is permanganate iron, and then will be purple in color. But I just want to draw your attention here. This is very, very important. If you remember the initial rate, it should be the highest rate, okay, throughout the whole reaction. But right here, you see that the initial rate, the tangent is like this, and in the process, the tangent is like that. So you will find that in this case, the initial rate is slow. Okay, this rate is slower than the rate afterwards. Why it have to be like this? This is a very interesting experiment, okay? Because in the process, okay, we will find that the two reactants that coming together, both of them, they are anion. When have anion and anion, anion and anion, they're going to have reaction. They will repel each other. This repelling each other, it will prevent the reactions to go very, very fast at the very beginning. So you'll find that the initial rate is slow because it involves two types of anion bond-bound to each other. They repel each other. So at the beginning, the reaction is very slow. But luckily in the process, we produce Mn2+. This is a transition metals ions. Okay, this can be used as a catalyst. Okay, it can catalyze the whole reactions, speed up the reactions. So as time goes by, they produce some Mn2+, which act as a catalyst to catalyze the whole reactions. So you'll find that, okay, the Mn2+ ion form act as a catalyst, speed up the reactions. So at the beginning, the momentum is very slow. You can see that the speed is very slow. But as time goes by, Mn2+ increase, the concentration increase. So therefore, more and more catalysts there, and the reaction will then be speed up. Okay, so this is a very important example of self-catalyzing reaction. Okay, so this is one of the very important examples, okay, about self-catalyzing reaction, and I want you to remember this one. Okay, very, very important. So next, okay, we're going to have to explain the drop in adsorbance in the reaction mixture. We're going to talk about drop in absorbance. So remember, absorbance related to color, color related to concentration of ion. So we're going to explain this part, okay. The concentration of permanganate ion decrease, so the color get fade, and then the amount of light absorbed decrease, so therefore absorbance will decrease. So again, concentration ion, color of solution, light absorbed, and finally get to absorbance. So our last part, we're going to find out instantaneous rate at two different times. One is 120 seconds, one is 225 seconds. As time goes by, you can see that the rate will get lower, and this slope is a negative, okay, because it want to show you the decrease in slope. Okay, just want to show you the negative sign of the slope because it is a decrease in the concentration of the reactants. Okay, so both of them will be in negative signs. Okay, so it will be like that. In these videos, okay, so we learned that, okay, we can monitor the rate, okay, by measure change in color intensity. The word goes to intensity, with colorimeter at regular time interval. Remember 3 steps. 1, 2, 3. When we're going to use it, okay, when there is a color intensity change, okay, not color change. Okay, so why does this absorbance will decrease? Okay, remember, concentration of ion decrease, color get paler, light absorb will change, and then the absorbance will lower. So absorbance, okay, is ranged from 1 to 0. It is a percentage, so therefore no unit at all. The limitation is, okay, we cannot measure color change. If you have a reaction change from orange to green, sorry, this method is not suitable to use it. Okay, so that's all for this video. Bye bye.